We'll start by accessing the AWS console and navigating to the Data Exchange service using the search bar at the top of the screen. Once you've accessed the service, you'll see the data catalogue. We'll be using a QIAGEN product for today's demonstration, so our first task is to find that product in the catalogue, and there are two means of doing that. Firstly, we could filter back to the specific healthcare and life sciences data, or secondly, we could search for the QIAGEN product that we're going to use, and that's what we'll do. So we'll provide this search terminology and click search. And we can now see the 5 products available in the AWS Data Exchange data catalogue. If we want to use this data, we'll need 2 things initially. Firstly, a place to store the data, normally an Amazon S3 bucket, and secondly, an active subscription to a product itself. We'll be using this QIAGEN Oncoland example dataset for our demonstration today, so I'll select that product. Once you've accessed the product, you can see a green banner at the top of my screen which highlights that I've already subscribed to the product. If you want to subscribe, you'll be able to click the Continue to Subscribe button, where you'll be prompted for some further information and get the chance to confirm the subscription with the data provider. Once the data provider has reviewed your request, hopefully that will be approved, and you'll find that data product in the Entitled Data section of the AWS Data Exchange console. Now that we have entitlements for our data, we can select our dataset to see the specific product. Below that, we can select our specific product, and that will show us the underlying data revisions, and they contain our data. Selecting the revision, we can see the assets or the files which the revision contains. And selecting individual assets within the revision, we now can choose to prepare the data with AWS Glue Data Brew, which is an extraction, transformation and load service, or we could conduct a number of export actions such as exporting the revision to Amazon S3, exporting just selected assets to Amazon S3, or downloading the selected assets locally. We're going to download our data to Amazon S3 to use it with AWS native services. So first, let's create an Amazon S3 bucket. To do that, we'll move to the Amazon S3 Management Console and click the Create Bucket button. Next, we'll provide a bucket name. We'll make sure that the bucket is in the correct region. As AWS Data Exchange is region specific, your products will be available in specific regions. When creating the bucket, we have other options around blocking public access to the bucket, and we'll leave this as default, blocked public access. We have the ability to add versioning to our objects within our bucket and tags so that we can effectively manage and automate actions associated with them. And equally, we can apply encryption on our bucket. We'll leave these all as default though and select Create Bucket. If that's been successful, we should see a green banner at the top of the page highlighting that we now have a new bucket. Moving back to AWS Data Exchange, we can now choose to export our revision in totality into Amazon S3. At this point, we have a couple of options around our export of the revision. We could conduct a simple export, which will just take these assets and move them to the bucket, or we could conduct an advanced export, including things like S3 key naming patterns. S3 key naming patterns will help us to structure the data in our bucket. If all of the files were in an identical format, we'd want them all in a single folder so that they could be read as a single table. But in this case, each file contains differently structured data. So here we'll want to separate the files into their own folders, with each folder representing a file or a specific table of data. So the first thing that we'll do is select our bucket. Once we've selected our bucket, we can then choose dynamic references, and here I'm going to choose a folder name first, and we'll use an asset name as the folder name, and we'll append that variable before adding a slash, and we'll add a second dynamic reference to the asset name and append that. We'll leave the remainder of the options as default and click Export. If that's been successful, you should see an export job at the bottom of the page. We'll give this some time to complete and I'll return and show you what this has done. Now that that job is complete, approximately 1.4 gigabyte of data will have been downloaded from Data Exchange to Amazon S3. If we move to our Amazon S3 bucket, we can now see we have a series of folders within the bucket, and each of these folders contains a file, and that file is essentially a table of data. How do we get access to that data? Well, we're going to use AWS Glue, which is AWS's extraction, transformation and load service to do that. We'll use crawlers first to infer a schema. We'll create a database, and the crawlers will create tables for us that will allow us to query that data. So the first thing we're going to do is create that crawler. So we'll click crawlers and add crawler. First, we need to provide our crawler with a simple name. So we'll use a simple name like my Oncoland crawler. Next, we'll be prompted to specify the source type of the crawler. We can crawl data stores, or we could crawl existing catalog tables. If we're repeating crawls of S3 data stores, we have a couple of options here. We can recrawl all folders each time we run this crawler, or we could only crawl new folders that are added to the bucket. So this helps us plan for different data patterns. Clicking next, we then get to choose the data store. We're going to stay with Amazon S3, but equally this could be a JDBC connection, a MongoDB, or an Amazon document database. Next, we will select a path in my account and we'll click Next. At this point, we're prompted whether or not we wish to add another data store. Here we'll say no and click Next. Here we're asked for an IAM role. This Glue crawler is going to access the underlying Amazon S3 bucket, so it needs a role to do that, permissions to access that bucket. The crawler can create this role on your behalf. All you need to do is provide it with a relevant name. So here we'll provide it with the same name that we provided the crawler. So our IAM role will be called AWS Glue Service Role -my -Oncoland -crawler, and we'll click Next. We then get to choose whether or not we run this crawler on demand, so a one-off ad hoc task, or whether we want to choose custom or regularly scheduled crawls of this data. As it's a one-off download, we'll choose to run this on demand. Next, we need to choose an output folder or an output database, so that once we've inferred the schema of our data, we can store that schema somewhere and allow us to query this data in place. We're going to create a new database for this purpose, and we'll call that my Oncoland DB and click Create. Once our database has been created, click Next and click Finish. We can now see my Oncoland crawler just over halfway down the page, and if we select that, we can choose to run the crawler, and I'll return in a second to show you the output of this crawler. Now that my Glue crawler has completed, and it took around a minute to do that, it should have created 8 tables for me, and you can see yes it has at the top. Each one of those tables representing an asset which sat within the Data Exchange revision. We could look at the individual databases and table metadata and configuration using these sections of Glue, but instead what I want to show you is the data catalog itself. So moving to Amazon Athena, which is Amazon's SQL query tool, we can now see our data catalog, my database, and a series of tables which represent the individual folders in Amazon S3. Moving to the right of the screen, we can see a query window and just running a simple select count. So all we're doing here is counting the number of records in this specific table, the probe level expression text GZ table. This is the large table within the data set, actually around 1.2 to 1.4 gigabyte if I remember rightly. Unfortunately, this data isn't yet optimized for cloud query, so as we can see right now, just conducting a simple count of the records, because the data set is so large, is taking quite a lot of time. So we'll let this complete, see how long it took, but then I'm going to show you some techniques to improve things like query speed with data that you've downloaded from AWS Data Exchange. As you can see on the screen, that count took nearly 40 seconds to run, scanned 1.18 gigabytes of data, and returned over 116 million rows. And a single query taking this long to execute will impact your ability to analyse and get value from this data quickly. So next, I'll show you how you can transform inefficient data formats like text format into an optimised format, specifically Parquet, using a simple query in Athena. The benefits here are 1. Query speed will be much improved, but also storage efficiency, so your data will take up less storage space. As an example, a 1 terabyte CSV file can be stored in a Parquet format in just 130 gigabytes. At this size, Parquet would be over 30 times faster to query, would scan significantly less data at that query, and would provide significant cost savings in a consumption-based model. We'll open a new tab to conduct that query, and I've already prepared it, so I'll just paste that now. The structure of the query, we're going to create a table, and we'll provide the table name here, probe level expression _ Parquet. And we're going to specifically denote the format of this data. So we'll say with format equals Parquet, and Parquet compression, specifically snappy compression. And in terms of the data that's going to fill that particular table, we're going to create that as a select start from the original probe level expression text data file. Once we click Run Query, that will begin to create a Parquet version of this particular table, which we can then query independently. We'll let this query run, and I'll return to show you the results of the query. It took just over 3 minutes 19 seconds to take that original text file and convert it into Parquet. So now let's take a look at the impact of that transformation. And what we can do here is we'll return to our former query, but this time instead of using our text file, we will use our Parquet file table. So we'll just run that select count again and see what difference that makes now. So as you can see, the runtime there was just 0.7 seconds with 0 kilobyte of data scans, and we have exactly the same output this time. So over 116 million records, except this time it took a significantly reduced amount of time to get that result. In this demonstration, I've shown you how you can download data from AWS Data Exchange, how you can use AWS Glue to infer a schema and create a data catalog, and how you can use Amazon Athena to query that data catalog and optimize your data formats. But where do you go from here? Well, now that we have our data downloaded into Amazon S3, and we have a data catalog, and we have a schema for our data, we're able to integrate this data catalog with the many and various native AWS services. As an example, and moving back to Glue, we could connect notebooks, whether that's SageMaker notebooks or Zeppelin notebook servers, to our data set so that we could begin to conduct some data science. Alternatively, if we wanted to process this data, we might wish to create Spark jobs, and that could help us potentially automate the regular conversion of this data, or maybe the movement of this data to a relational database or a data warehouse. And that's the kind of final element I'd touch upon here. We can create new databases and new connections to different data stores to enable us to integrate this data not just with the AWS services, but also with your own business processes. Hopefully this has been helpful. If you'd like any more information, just reach out to your local AWS representative.